something very exciting happening in Lancaster at the university. We have developed a compound which we think has the potential to at least slow, if not stop, Alzheimer's disease. The pathology of Alzheimer's, now I know that some of you will know this, but Alzheimer's, the first thing that Alzheimer saw when he looked at somebody's brain underneath the microscope were these plaques and tangles. And this is a photograph of a very thin slice of brain tissue. And I don't know, not particularly clear, but just over here, can you see it's got a dark middle and sort of a circle around it. That's a bit denser. That's called a senile plaque, and the plaque is made up of a particular protein called beta amyloid, and it clumps together and it surrounds the cells, the brain cells, the brain nerve cells. Along with those plaques that develop on the outside of the nerve cells, you get also these tangles which are inside. So here you can see the long stringy bits of tangles that are made up of another type of protein. They're on the inside, and the actual plaques, the senile plaques that Alzheimer himself saw, are on the outside. And ultimately, what happens is that the brain nerve cells get clogged up. They get clogged up on the outside, and then the stuff in the inside, and they get very weak, and then ultimately they will die, and you get enormous tissue loss with somebody with Alzheimer's disease. So the fibres on the outside are made out of a particular type of protein called beta amyloid. We think that the beta amyloid starts off as single molecules, and as single molecules, we all have these in our brain, and they are not a problem at all. But for some reason, we think that maybe the brain makes too much, or we can't get rid of it quickly enough, but the concentration goes up and it starts to stick together. So we get these little clumps, which we call oligomers, and then the little clumps all stick together to form a thread, like a fibre, and then the fibre twists round itself, just like we saw in that photograph. I mean, and this isn't an exaggeration. Anything between 30 and 40% of the total mass of the brain is lost in somebody with advanced Alzheimer's disease. It's almost difficult to comprehend how somebody can even live with such an enormous loss of tissue. So, as the disease progresses, we get this substance building up, this beta amyloid protein, we get the plaques and tangles, then we get the loss of the nerve cell connections, which ultimately results in the nerve cells dying, and then we get this catastrophic loss of brain tissue. So that's the team. So that's me. That was before Fringe. Fringe now. So this is a very, 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 very basic explanation as to how our drug works. So this is supposed to be one molecule of our beta amyloid, and one part of the molecule is sticky. And it's due to this sticky part of the molecule that the whole thing sticks together. And our drug, very simply speaking, covers up the sticky bit to stop it sticking together. So these are the single molecules, all with their sticky bits. Okay, so this is what happens in Alzheimer's disease. So it all sticks together. So we get from our single molecules to our small clumps to the fibres. So that's what happens normally. But with our drug, okay, which is signified by the tablet, so the tablet sticks onto the sticky bit and it stops them sticking together. So it actually blocks that progression onto the toxic molecules, and it also blocks the formation of the fibres. So we've managed to put a chemical tag to pass it over that blood-brain barrier, and we know that it gets in. It reduces the plaque formation, it reduces brain damage, and we know that it does this in cell models. And strangely enough, it actually encourages cell growth. And we know that it protects against memory loss. So, and we were the first group in the UK to actually prove, up to this point, that our compound can preserve memory. So it's all looking good. So we set up the campaign, Defining Dementia, actually about this time last year. We set it up. If it works, and we think it will, it could be enormous. It could be groundbreaking, because there's nothing out there really that's been shown to have much effect at all. And now I'm actually working for the clinical research organisation which is taking the compound on. Now MAC are they are the largest UK company which are totally committed to doing clinical studies. We're hoping that we're going to get a clinic at Lancaster. So, for the first time, Lancaster people are going to get choice. And it's going to be the case that hopefully, in the future, a Lancaster-developed compound is going to be offered in the Lancaster Clinic to people in Lancaster. That's good. Excellent update. And that's it. Thank you very much. Any questions?